Jake Schwanke, and today's topic is cars and how they work. I'm sure you know they use gasoline and an engine to move you about, but there's obviously more than that, right? Well, there is. Today's feature is about how cars use chemistry to get you from point A to point B, and how different types of octane can do that differently. Car engines are like mini chemical plants burning gasoline to make energy. The car converts the energy into motion, but why gasoline? Why do we burn wood or boil water to make cars move? Seems like it would be better for the environment. Well, we don't burn these things because they're not as energy efficient. Gasoline is made of hydrocarbons, and when these molecules burn, they create lots of energy in processes called combustion reactions. The reactant, in this case the hydrocarbons, burns with oxygen to make a product and lots of energy. Other materials, like wood, also have hydrocarbons. When you make an open fire, that's combustion. However, an open fire isn't very efficient. The energy goes everywhere. The engines are made to maximize the energy received from the combustion of gasoline. So when you put gasoline in your car and go for a drive, the gasoline is reacted inside your engine with oxygen to create lots of energy, which turns the wheels. This is called an exothermic reaction, meaning that energy is released. The following reaction is an example of some of the hydrocarbons found in gasoline reacting with the oxygen to make carbon dioxide, water, and energy. We have 2 molecules of C8H18 plus 25 molecules of O2, and that creates 16 molecules of CO2 and 18 molecules of H2O plus a certain amount of energy. So now you know how gasoline works, but did you know there are different types of gasoline? You will always see 3 types of fuel in a gas station. There's a regular, plus, or mid-grade, and then a premium gasoline. But what do they mean? These are the grades of fuel measured by octane ratings. The higher the octane level, the more resistant to accidental and premature combustion the gas is. In the US, the levels of octane and corresponding grades are as follows. Regular is 85 to 75, plus or mid-grade is 87 to 90, and premium is 90 to 95. The grades of gasoline all contain equal amounts of heat energy. However, their combustion levels vary. Normal vehicles are made to burn the optimum amount of gasoline, so they don't benefit from any grade higher than regular. However, if you have a high performance or sports car, then you will have to do a better job at keeping high-grade fuel in your engine. Essentially, the higher performance of your car, in other words, your car's like expensiveness too, the higher octane that it'll need. Regular everyday cars only require regular unleaded gas. If you put high octane gas in a normal car, there will be more harmful emissions. This is because the higher octane gas ignites quicker than the normal car engine is designed to handle. So more unused gas will be ejected from your car. So use the right octane for your car. In recent years, there's been a lot of talk about the greenhouse gases that cars burning gasoline make and alternative fuels. This makes sense because a single gallon of gasoline produces about 20 pounds of carbon dioxide. Alternative fuels are real, but aren't as popular for many reasons. Either the cost, fuel efficiency, difference in mechanics, or hard to get fuel turn people away from using alternative fuels. However, as the technology develops and they gain more and more attention, more people will start to use them. Electric cars and hybrids are also gaining popularity as they do not have as much harmful emissions or use as much gasoline. Cars are an amazing invention that changed transportation completely. They burn gasoline to make energy to move you around. There are many different types of fuels and even gasoline. The most common fuels for cars have different grades. Gasoline produces water, carbon dioxide, and energy when burned with oxygen. And new fuels are on the rise. What will the next big innovation be? Well, buckle your seatbelts and come along for the ride. Maybe you'll see. I'm in love.